So we talk about 0.4 nanoseconds. So that means the speed that you can process one instruction, like load, load, load the data. I can load it in 0.4 nanosecond. I get it at boom out right away. Load from the memory. Remember, it's stored at letter A, come out right away. Okay, because this is a frequency here, right? So the process may take only 0.4 nanoseconds to finish that process. Which now we're going to get into the level of instructions. Like for example, what's instruction like when you do printf command to like system.out.print, right, in Java. That is instruction, but in the human level interface. Human who knows the program, right? But in the machine, that instruction turn into that statements or coding turn into instruction sets. Okay, in the lower level. So let's look at the lower level. So so what we do, I want you to look at this image, okay? And read this part first, like the level on that image. Okay? Give you maybe a minute. And try to understand it first. Alright, anyone want to explain me? What will you capture from that image?
All the different levels from what the computer reads and understands to what these users see.
Right? So from the upper level, right, until the physical level. So upper level is human, right? And physical level is hardware that we just talked about on your motherboard, right? And CPU, right? That makes sense? So you see that there are many layers that we have to translate to get to that point. So the first layer, let's talk about first layer. Level 1. So let's go to it from the top, level 6. So the user only know how to do executable, like launch the app and play with the game or whatever app is going to be, right? Use the app. And level 5, how do we create an app? You use a high-level language. Could be Java or any language, C++, Fortran, and etc. Now we know that Java is high language or C++ they are. Now the computer language they also have categories like higher and lower. So higher because it's close to human language, easier to read and understand, they call high language. So you can write a program to create an app for the users with a higher language. But it's going to get, remember, it's going to have to get into that 0101 computer language level, machine language. So it's going to translate to assembly code. So assembly code, so let's look at an assembly code. Like this class, we're going to talk about assembly codes too. You have to learn and one assignment and also test. It's going to be a challenge test. You have to write a code in assembly. Okay, that's why all the assignment is important. Yeah, some example. So that assembly. Can you really read it at your level now? I mean, we cannot read because it's too small, I guess. So let's look at, here you go. This is some of the assembly codes example. All right.
There is just one. Some people,
Hmm?
yeah, some people, there is just one, like one version.
Oh, there are many versions.
Not version, I mean, there is just one for all machines. Not like high level. Some assembly.
It depends on the CPU architecture. Each CPU has its own assembly, but you can use a standard one too. But for our class, we're gonna use Mary assembly. We're gonna make it so basic. Machine Mary stand for reduced instruction set. Machine reduced instruction set. I try to think about E, right? Mary. Yeah, assembler. Okay. When you go to the course website, you should be able to see the directions how to download Mary, and that's gonna be one of the assignment too that you have to do. And it's important for you to do. We're gonna talk about assignment. This is Mary in assignment 4, and this is this Mary language. Uh, yeah. Okay. So if you go to the web links, Mary simulator, you can get from there. Okay. All right. So that's just simulating a CPU. Now, when we talk about assembly, we get to a level that we can manipulate our CPU directly. Okay. So, for example, this move stand for move. AL stand for it's a register, the name of register. Okay. L lower bits. They have in the architecture they have AX, BX, CX, DX. Just the name of an array with a register section in your CPU. Okay. Let's see if I have a AX, BX. Yeah, CX, DX. Let's see if I have good images. Yeah, right there. So this is just a portion of CPU that we call register, right? They're gonna separate into AX, BX, CX, and DX. This is for data, to store the data, period data, like a letter A. And this is 16-bit architectures. Remember nowadays 64 bits. 16 bits, 0 to 15. If we talk about bits, that binary number here, they're gonna line up. So if I'm dealing with 8 bits, I only need AL to store data. So you can look at like X equals to a letter A, something like that in Java, right? So X pretty much just going to get allocated like, okay, if you declare byte data type, I only allocate AL to use. If you can declare 16 bits short, then I use AX to store the whole data. And that value that you give in the higher level language is get translated into assembly in hexadecimal numbers and store them in a binary format. Okay. All right. So that's just a brief overview, just like that. So you see hexadecimal number 61. We said 65 is A, right? You look back into ASCII. Oh, say it again. Oh yeah, in decimal, you're right. So this is, you see 97 in decimal, but 61 hexadecimal. So you can look back onto ASCII table. Where is it? 61, right? 1 second. In hexa, a small, yeah, lowercase a. So now this is how you read assembly, right? I just move lowercase a go there to store that register directly onto your CPU with that instruction, which you cannot do with Java. So that's why assembly you can manipulate at hardware level. You can control your CPU directly if you know the assembly language. And normally, yeah, engineer they use that because they have to design the hardware interface. Okay. At your level, you just understand, okay, at least how to manipulate it, how it works. Because it's important when you write a program, right? You need to know how the physical machine really manipulate that data or process data. Because sometimes you get something that you don't expected. So that's assembly language. We've seen it. That's level. Like OS, going to go into another layer, operating system. Going to translate that assembly into machines because assembly is still not 0110. Now let's get to instruction set architecture. Like that mv command in assembly move, how we actually move it is get into instruction set. Which is another chapter, I think chapter 4 that we're going to talk about. We have to have a design of instruction set, like we're dealing with the architecture like 16 bits, 32 bits, 64 bits instruction sets. That we talk about 64-bit machine now. And think about, okay, when we get to that, it's still kind of how are we going to talk to that hardware, right? It's like brick, right? So it's still software here to help. When you get to this level, it deal with, let me show you an example of instruction set architecture. You see that, oh, chapter 4 is memory, right? So it's chapter 5 then. Yes. We can get into details. I just show you an example first, how it looks like. These are our architecture. Yeah, it looks like that. This is like assembly, right? And it's get translated into that level. don't have breakdown. Let me see. I think chapter 6. Here. Right here in chapter 4. Again, this is all you pretty much need to pay attention because all of this is gonna be on your test. Okay. So it's gonna break down into like that level. Okay. And then when we get to that level, yeah, this is hardware, right? Close to hardware level. So let's come back to now. When we get to that level, it's like dealing with more into 0110 level, which we talk about CPU. Right? CPU has like the gates, circuits, right there that it design all the wiring. That depending on it could be software, which is microcode. Now when we talk about software, think about if I want to turn off the light switch right there, it can be use software, right? I can use software to do it. Or I can do hard wiring. I can go to switch and manual turn. So that's why it can be hardwired. So it's all supply like 0 and 1, like 0 and 1 is power or no power. That's it. Oh. So everything that is hardware can be replaced as software. Just like if you think about the old time phone, we use that real hardware button. We can just use software now, right? Like touch screen. Everything that's hardware can be replaced with software. So that's why you can either do hardwired or microcode, which is we're gonna have another memory that take the CPU process and software on the board, like BIOS. Okay. All right. I think that's pretty much it for us today. So the assignment that I want you to prepare, I want you to look at assignment 1. You're going to do the presentation on your research paper. You can pick any topic. This is just suggested that you interested to talk about. Okay? Any topic that relevant to computer architecture, design. Alright, and you have to follow these rubrics to get a full score in your paper. You just have to talk about each of these components. Alright? Okay, let me call the roll and we can call it a day. Thank you.